Zip.
Zap.
Zop.
No, you gotta go to someone.
Gotta go to a person.
And then you start again.
Yeah, no, theater's
I don't
terrible.
know that.
Theater's
Oh, is that a
terrible.
theater thing?
It's a theater
It's
thing
an
to get
improv
everyone
thing.
into.
Oh.
Theater's awful, but we're going to put on that show.
Paying attention to
Eventually,
your other
that keeps
people that
happening.
you're interacting with. Welcome to Walkabout the Galaxy, the occasionally live astronomy podcast where the science is universal, the opinions are personal, and the hosts are back in the studio. We are Strange, Charm, Top, and Down, the Astroquarks, also known as Josh Caldwell,
Addie Dove.
Jim Cooney.
And Audrey Martin.
coming to you from the Walkabout studio at the University of Central Florida. We are happy to be back in the studio after not one, but two consecutive live podcast recordings that Jim missed.
I missed both of them.
Both of them. Jim does not venture outside the studio. I think is
Yeah.
Apparently
what we've
not.
learned from.
Home and studio
I'm
direct
sad. I'm
link.
sad because I think the one time I did that, it was a lot of fun.
You're like the Beatles in the late, at the end of their careers, like
that's
not
true.
touring anymore, just in the studio.
Not
Yep.
that you're at the end of your career, Jim.
Yeah. We'll have to supply our own audience applause for this episode. Oh, that's awesome. You guys, yeah, that's great. You guys can keep applauding every time I say something.
Or I
Oh.
say something.
Is that what happened at the live performances?
Yeah.
Every time you said something?
Josh spoke.
Yeah.
Every time,
Yeah.
Whenever he
every
paused.
time I
Yeah.
shut up, they would applaud.
Oh, so there was actually no applause.
That's right.
Yeah.
Remember to subscribe to us on all platforms. You ready, Jim?
Yep.
Including YouTube,
Uh-huh.
Facebook, Twitter, and Instagram, but not 8tracks.com, Yo-Yo-Mat, or Neopets. Which one did I make up?
Neopets is real.
Yeah.
8 tracks.
I don't know. The middle one is like what, like
Yo-yo-
cello porn?
Yo-Yo-Mat. Cello porn.
Yo-yo map.
You
one
made
is
that
it?
one up.
You went with what?
Yo-yo mat.
Yo-Yo-Mat. You're saying
Yo-yo
Yo-Yo-Mat?
mat. And I said the first one.
8tracks.com. It's Yo-Yo-Mat.
Yeah.
I was going for something kind of like, it could be a yoga thing.
Yeah.
It could be.
Could be a yoga thing.
Yeah.
I like it.
Could
Or
be,
it
but
could be
it's not.
something with yo-yos. Or
Yeah.
it could be cello porn.
But it was none of those. It still could be any of those things, actually.
True.
Maybe we should get that domain name.
Apparently, John Oliver when he does all these ridiculous things and he makes up websites. Apparently, he has to buy the domain name
To make it
to
up.
make that to like say that web. I don't know if this is
Oh.
true, but that's what he said in the recent episode. Is that he has to like buy the domain name to like
So
have
they
that then
can
in the
say
show.
it's a made-up name. Yeah.
And
That's
then they have
amazing.
it. So they
Yeah.
have like these
They've got
ridiculous
50
ones that are
crazy
super
names.
funny. Yeah.
We should do that.
You should.
You can contact us anytime at wtg@ucf.edu with questions, compliments, and to find out how to get a cool Walkabout t-shirt. Our stumper today is another planetary fantasy stumper.
Ooh.
If you could change our star to a different spectral type while maintaining Earth in its cozy climatic environment.
Sure.
So we're still at the same habitable zony type thing. But that could mean much closer to the star or much farther from the star. It could mean therefore a shorter year, longer year, different color of the star, all those sorts of things. What kind of star would you like to move the Earth around?
I don't think I know enough about stars.
Get out!
Jim, go first.
Oh, I'm going with like a.
The star guy.
Well, I'm not a star guy, but
Closest thing here to a star guy, probably. Am I
going-
more of a star guy
We're
than you
all
are?
the same distance.
so-
We're all
so-
the same distance from a star, y'all.
I've taken graduate
Y'all.
stellar astrophysics.
I did not take stellar
Okay.
graduate
How about you,
astrophysics.
Addie? Did you take stellar astrophysics
I
at
did,
Colorado?
I think.
Right, so we're the two star people.
You
We're the
guys
two
are star
star
people.
people.
Okay,
All right.
you go
Fantastic.
first then.
Stars.
I figure
We're just
the
the
stars.
stars. It's fine.
Stars, I figure they're like roughly, in a geometric way in between what you guys study, and what I study.
Hey,
So-
what's your answer to the stumper?
An O star.
Somebody's got
That's a
pointed.
good one.
I want the biggest, baddest, shortest lived star.
Just
I
to,
want
like-
because I'm so disappointed that the sun is never going to go supernova.
Sure.
Okay.
Like it's just going to
You're
die in
not
some
mad at the
wimpy
sun,
way.
You're just
It is.
disappointed.
I'm
It's
just-
gonna,
disappointed.
it's gonna blow up and maybe swallow us.
I mean, it's going to do some cool things, but like I want
True.
You want the star
I
to
want
blow
I
up.
hope Brendan's
freaking
listening.
supernova.
And you want it to be doing that in like millions instead of billions of years.
Yeah, I want that to. Like,
Yeah.
I want it to be on the
Cool.
edge. Like it could happen tomorrow.
You want to have some
You want to be around
existential
Beetlejuice.
Yeah,
crisis added to our
that's right. Because I'm not anxious
Currently-
enough.
to our currently humdrum existence.
That's
Yeah.
right. That's right.
I don't know if I would want a different. I don't know exactly which spectral type, but I want a variable star.
Oh.
Like a Wolf-Rayet or something.
stars.
But like
That's-
those are so Wolf-Rayets
that's-
are very early stage, right? But like a Cepheid or something,
a
right?
Cepheid
Where it's a
variable.
variable star.
That's going to be tough to
That
maintain
is
that.
gonna be tough.
Well, we
habitable
have
zone
we have
orbit.
magic, so I don't care.
Oh,
That's
okay.
right.
All
We
right.
could, since Cepheid variables are periodic,
Yeah.
you could put the Earth on the
You put little
exactly right
boosters.
elliptical orbit,
There we go.
so that
Yes.
the periodicity of the star's variability and the ellipticity of the Earth's orbit magically keeps it
No.
in
Yeah.
the habitable zone the whole time. Actually, it'd be
I love it.
interesting.
It'd be interesting to do that calculation. That
You
sounds like
can't-
a great.
that's
That
possible.
sounds like
Can't
a
work
great. That
It-
sounds like a great origins.
Can't work
It, it would be
Because the variability of those
remarkably
things
lucky for it
is
to work
hours
out.
or days.
Yeah.
And not
Cepheids have a pretty not all Cepheids. Some Cepheids
maybe
have a
weeks
longer
or months,
period.
but like
That's true.
they
Okay,
are
well, we'll pick a variable
very
star that has a
big,
yearly.
bright stars.
We can pick a variable
Cepheid
star
variable stars are very
that
big
has a
bright
more
stars, so
yearly
you have to be very far
periodicity.
away from them. And
I'm gonna keep talking over you.
Oh yeah.
Yeah, nobody
Sorry.
has heard anything that either one of you has said.
You can
I'm
adjust
so
the volume in the
lost.
tracks to make one of us
I
more
can't
prominent.
actually do that.
Sure you can.
I'll tell you what though, I like adding a little letter over
I
there.
actually
Letter had that star.
Thanks. It's a hypothetical and a stumper.
Sure.
Yeah.
All right, let's move on.
What's the I actually have another question though about that. What's the magnitude of the brightness fluctuation for a Cepheid variable? Like how much brighter does it get from its dimmest point?
That's a good question. I don't know the answer to, but I want to say it's on the order of. I mean, it's a lot, like
It's not
10%ish. Yeah, like not.
10%.
But that could be wrong, but not.
The thing is, if it's a very bright star, the habitable zone is not only far away from the star, it's also big.
It is big.
Mm-hmm.
So maybe you could deal with a 10% fluctuation.
That's true.
You know.
It's over approximately 5 orders of magnitude.
Five.
Absolute magnitude numbers.
Oh, that's much larger than us.
5
It goes from
magnitudes?
-1
What?
to -6 in absolute
single star?
magnitude over 90 days. I don't know. This is the period luminosity curve for a Cepheid.
Oh, that's not saying, that's saying if you know the period.
Oh yeah.
What's
Sorry,
the-
that's the wrong
what-
plot.
yeah.
Good point.
Yeah.
Good point.
All right. Audrey,
No, here's a good one. Oh,
There
it's
you go.
like 2
two things. Two
magnitudes.
That's
Oh, that's a lot.
That's still a
That's
lot.
a lot. That's not 10%. That's
No,
a factor
that's a
of,
factor of
5 or
Many.
something.
yeah.
Yeah.
Okay, Audrey.
Ooh.
Nobody remembers what we're even asking anymore. What kind of star would
what
you
kind
like
of
the
star?
Earth to orbit?
The
Oh,
radii
boy.
also change with that pulsation cycle.
Really?
Yeah, Cepheids
Sure.
are cool, y'all.
I want another Cepheid, but I want it to vary on a daily basis, and I want our orbit to not be elliptical. I want it to, kind
Alright.
of follow like a flower
I didn't-
kind of thing.
Sure.
Come on.
Ooh, a type 2 Cepheid is only like
I
half
thought
an order of
We
magnitude.
could use
so.
magic here.
We're protected, you
It's
said.
limited magic.
It's-
I'm going to go with the opposite end just for fun. A cool, dim red star.
Mm-hmm.
Say I have a really fast year, a short year, so I can live to be 200 or maybe 1,000
Nice.
years old.
Nice.
And you're close to the star.
Yeah.
So like you can see, you have a
Sure.
big old whopping star in the sky,
Right.
and you get out your solar
Then
filters
it's really hard
on
to your look at the
binoculars, you
sky.
can see
Yeah.
things.
Because you're not supposed to
The
stare at the sun.
downside though is
Good point.
it's dim, so it's like the
Mhm.
whole visual aspect
Yeah, is
of like
everything-
seeing.
Is everything?
Our
Are
eyes
you
stay
always
the same.
wearing
Maybe we-
rose-colored glasses?
Yes.
Maybe
Sounds
we would
nice.
evolve infrared eyes or something like that.
Yeah.
Not
that's
us
true.
personally though.
Well, maybe we
Oh.
did
Oh,
in this
right.
scenario.
No, there's no evolution there.
Oh.
Guys, you're getting carried away with this stuff. Today we'll talk about asteroid impacts on ancient Mars, planets lurking in surprising places, and a new type of observatory, among other things. But first, this episode of Walkabout the Galaxy is brought to you by 5 Sigma Detection.
Whoa.
Nice.
Hold on.
If you're tired of looking for that needle in a haystack, get 5 Sigma Detection to make it stand out from the crowd. The gold standard in particle physics, with a 99.99994% likelihood that you're not just looking at a chance occurrence. With 5 Sigma Detection, you can stake your reputation on your results. Act now! And for a limited time, you can upgrade to 6 Sigma Detection at no additional cost
Whoa.
to reduce your
Whoa.
odds of a fluke even further to 1 in 500 million. 5 Sigma Detection cannot be held responsible for systematic errors. For your next great result, get 5 Sigma Detection. Double your pleasure, double your fun.
Doublemint.
You are correct.
Oh, Trojan.
Oh God.
No, it's don't. Yeah.
Asteroids.
Trojan asteroids.
Yeah,
Trojan
yeah,
asteroids.
Trojan asteroids.
That's what you were referencing.
Mm-hmm. Sure.
There's 2 sets of populations of Trojan asteroids. That's why he said it.
Yeah, by the way, it was a very nerdy sponsor message.
It was. I liked it.
I liked it.
Most of
Oh.
our sponsor messages aren't very nerdy, so
No,
True.
just even more nerdy. I don't know.
I don't know. I think you just haven't been here in a while, Jim.
Oh, really?
Yeah.
Okay.
That's true. Yeah.
I wanted to go back to something, but now I don't remember what it was, so it's fine.
Yeah. So there's a lot of interesting space news, or at least there's a little bit of very interesting space news. Let's put it that way.
There's a lot of bit of
So the
Big
super
space news.
heavy, Jim, I'm sure you were glued to YouTube.
Which company is this again?
SpaceX.
SpaceX, yeah. I
Elon
remember that.
Musk's
Oh, it
company.
is?
Elon
Yeah.
Musk, SpaceX
This so
company.
we've Audrey and I have discussed this, and this side of the table
Yeah.
doesn't know rocket stuff.
No.
Oh.
we
What?
don't.
What? Yeah.
Yeah.
So to the listeners, Audrey and Jim are across the table from
the
me.
directional
Yeah.
quarks. The
Yeah.
directional quarks don't know their
Don't know about rocket
don't know
bits.
their
Yeah.
rockets.
We like rockets, but we just don't know.
Yeah,
Yep.
they just don't have the vast history of discussing them that Josh and I do.
Yeah.
That's what it is.
So this is, I mean, come on, this is the most powerful rocket ever.
That ever launched,
By
and now they can say that.
A significant amount.
Mhm.
Is
feel
more
like-
powerful than SLS.
I feel like that keeps happening though.
Yeah.
Well, it
has to.
It is.
So
pretty
when
interesting.
is it gonna stop?
It's never gonna stop.
Oh.
I think
Can't
it's
stop,
going to
won't
stop
stop.
with this one, actually.
Well, I don't know
I
how.
think it's going to be a long time.
Sure, because like New
Before
Glenn, New
New Glenn is a New Armstrong. Which
Armstrong,
is a
that's the one.
hypothetical one. Or
I
whatever.
thought-
is even less. It's still not as powerful.
As this,
Yeah.
yeah.
New
I think-
Armstrong is Blue Origin's hypothetical moon rocket. New Glenn is their orbital rocket.
And even New
Shepard
Glenn
is their
hasn't
current
launched
suborbital
yet.
rocket.
So how does this one compare to the
It's
one
bigger than SL or
The
more
one-
the one they
powerful
launched,
than
I don't know what
SLS.
So
the hell
what-
SLS is. I'm talking
Here's-
about
Yes,
the
you
one
do.
they launched the Apollo missions on.
So
That's
a
the
Saturn
Saturn
V.
V.
Yep, that's a big rocket. I've
And
seen
the-
that one.
And so the SLS that
Same.
launched recently, which was the Space Launch System that NASA built that launched the Artemis capsule,
Right.
that one was more powerful than the Saturn V.
By about 20%.
Okay. Okay.
And we're
okay.
and we're measuring power by thrust,
Thrust.
at liftoff.
Thrust that liftoff, right? Right. Okay. Makes
So
sense.
that's
I'm in.
a unit of force. And for Saturn V, is about 7.5 million pounds of thrust at liftoff.
That's a lot.
And the SLS was like 8.2 or something like that.
Okay.
And
then-
now-
and then this,
10%.
And so
and
super
then this
heavy
new one is.
It's like twice as much.
It was like twice. It was
Oh.
ridiculous.
Twice as much as which one?
as Saturn V.
Saturn V.
Yeah.
So it's like 13,
It was
14,
definitely
something.
well over 10.
So is this
Yeah.
the one? I
Million
mean, this is the
pounds of
one that.
thrust.
So this is
it
the
seems
one-
like that Elon Musk founded this company to get to Mars and
Yes,
to
this
like
is- this is
colonize
what's
Mars.
supposed
This
to
is
do
the one
that.
that's going to do that.
Yes.
Okay.
This is the one that will carry a giant thing up into space that can then go to
Right.
Mars, for example.
After it
Okay.
carries 10 other giant things up into space
Right.
to
So
get
fuel
that
it.
one thing to get to the.
Right.
But they
right,
didn't
right.
put anything into space.
They did
just-
not
They
achieve
did not
orbit.
put anything into space. That's
Exploded
exactly
it.
right.
They just exploded
Exploded
Starship.
it. Okay.
So,
Rapid,
so this
unscheduled
was
disassembly.
This was super heavy at the bottom, which has 33 of the engines that they
Raptor
have on
engines.
like the Falcon 9. So the Falcon 9 has 9 of them. This one has 33 of them.
Whoa.
They should have called it 33.
The 33.
Yeah.
I know.
For just for me.
Falcon 33.
So I can remember.
And then it had a Starship on top of that,
Which has 6 of
which
those
has
engines.
6 of it, those
So it's
engines,
like
but those
the
weren't
second
firing.
stage?
It's
Okay.
like a
Yeah,
second
yeah.
stage in
Yeah,
this
okay.
case.
Gotcha.
So it was supposed to separate. Those would fire, and it would go. At that bit would go into orbit.
Right.
But it didn't separate, and then it went boom. Well, then
Oh.
it did a few flips,
Yeah.
and then at one point it looked like it was a missile going downward,
Oh god.
and then it went boom.
Maximum thrust 16.7 million pounds. So
that's like twice as
more
much as
than
SLS.
yeah.
Wow.
It's more than twice as much as the Saturn V pounds of thrust.
That's a big rocket.
Wow.
That's a big
Yeah.
rocket.
Zoinks.
Yeah, and
Zoinks.
of those 33 engines, though, it looked like some of them
Five.
never actually fired at all.
So like 3 did not fire when it first started. It had, they conveniently had a little graphic at the bottom that showed the configuration.
yeah,
and when
that
it
was cool.
first lifted off, there were like 3 that just blinked out,
Yeah.
and then 2 more blinked out pretty soon after that.
Yeah,
But it still.
It
it
got
went
up,
up there. It went
somewhere.
up about 100,000 feet or so.
And man, it was so slow.
it looked very
it looked
slow,
very heavy.
but
You
it's
know
partly
how,
because
like-
it's so
yeah.
big.
That's
right?
true, but I think it also was just slow because it is so big. I don't know.
Yeah.
Like to get something off the ground, if you launch a little thing, like if you're doing model rockets, you can
Oh, yeah.
launch like a big rocket with an engine, or you can launch a little tiny, like I used to do a quark. I know, with a little engine, and that thing will just go, psst, right? And the bigger ones kind of go, boom.
Yeah.
Yeah.
This
It definitely
one-
felt like a.
I'm
But-
trying to get it off.
Yeah.
One of the interesting things, though, is so if you looked at the data, which I'm guessing was correct on their live launch display or whatever, it shows the speed of the rocket.
Yeah.
And it was showing it at like 120 or 130 kilometers per hour. It's like 60 or 80 miles per hour.
Like from the beginning?
When it looked to me like it
was
was
barely
going 5
moving.
miles per hour.
Oh, interesting.
So they
It-
were lying.
Or
it's
the
just a
scale.
perspective
Our
thing.
brain is thinking that is moving very slowly because we can't comprehend how gigantic it is.
It's true.
So for a gigantic thing to go its length
That's
in
true.
a second is going very fast. But we're thinking
Right.
about how long does it take if a car goes its length in a second. Whatever. You get what I
Yeah.
mean, right?
Yeah.
So I don't know.
That's
Anyhow,
true. Maybe.
yeah. But it did look very
So
slow,
slow.
and then it went boom.
Then it went.
Yeah.
Mm.
The other space news is
Supposedly
more,
they're going to do another one in just like
Oh,
a few months.
Oh, really?
He says 1 to 2 months, and I was going to ask for people's takes on the fantastical nature of that prediction.
I mean, like, they probably have the stuff ready to go, right? Like, the way they're putting these out, they probably have another heavy
Yeah.
thing and another starship that they're going
Right.
to stack, and they probably can be pretty ready
What
to
they
go.
what they don't have
They
is
have
a
a different.
launch
They have a different
pad.
launch pad, from what I heard. They have another one
Oh,
that's ready
Really?
to go.
Oh.
In the
Where?
same place. This launched from Texas, right?
Yeah.
Launches from Boca Chica, Texas.
And they have another one at that same
At that
location.
site.
I see. Because they
They
destroyed.
destroyed the launch pad.
Really?
Yes.
Yeah. There's
Yeah.
some epic images of
Yeah,
the
they-
But
crater,
that's not
the crater
because it
underneath.
exploded, right? That's
No,
just from the
That's
launch.
just from the launch.
Well,
They
as
didn't.
you said,
They
it
didn't
exploded like
really build a
100,000 feet.
full like if you think about the pads at Kennedy,
Yeah.
they're
Yeah.
like these massive structures that have a lot of engineering in them, right? They have
Yeah.
flame trenches
Yeah.
Right.
where you
And the sound, the
and
water
the
sound
sound
suppression system.
which is actually the biggest mechanical problem, is the water that shoots at them isn't for the fire; it's for the sound. So
Right.
it suppresses the sound, which is like
Damps
this
acoustic
acoustic
waves.
stuff is what destroys all the stuff around typically.
Oh.
And for some reason,
it's
they
not the
didn't
heat and
do
stuff?
any of that.
Because I
And
think they didn't care.
I saw some speculation or statement, I don't know if it's true or not, that some of those engines that failed failed because concrete blocks got blasted up into the engines.
It looks
No
like there was
way.
stuff flying very early.
Yeah,
I
because you're
wouldn't be
turning on
surprised.
33 engines, so
Yeah.
like when the first 10 or 15 or
They
20
can't be exactly simultaneous.
turn on, you're getting crap flying around that could damage those same engines
my
because
gosh.
you haven't really started moving yet.
Yeah.
So
Yeah.
it seems like it was
Seems-
maybe a little bit careless to not
Well,
have a better
that's sort of
launch
their
pad. But our other space news is a
Other
more
things
successful story.
Well, this is kind of borderlines. But so, you know what the coolest telescope in the world is?
In the world?
In the world?
Ice Cube.
No, it's JWST.
Oh.
But so
I like
we
the
keep
ice
talking
cubes.
about that. In fact, I think one of our topics later we'll come back to
And
JWST.
the
Yes.
J-Wist.
But you know the problem with
corner.
JWST is it's so freaking expensive. You know how long? We've talked
It
many
was
times on the program how long that took to get up there, how expensive it was.
years over schedule and billions of dollars
Billions
over
of
budget.
dollars over budget.
Billions and
Turns out that you don't really. That's great, but you can do a lot of science on the cheap, and so a really cool.
It's our motto.
At least the cheap part is.
Yeah.
That's kinda cheap. No, but there are much cheaper ways to do it. You still want to get out of the Earth's atmosphere as much as you possibly can. So one cool way to do that is balloons. So I just saw they recently turned on a balloon-based observatory called Superbit. A fun, cute
So
name.
cute.
It's like super.
What kind of
pres-
telescope is it?
It's mostly a visible light telescope. It
Okay.
goes a little bit into the infrared, a little bit into the UV, but mostly a visible light telescope. And it's not that big a telescope. It's only half a meter.
It's the same
telescope.
size as our telescope here at UCF.
Right, not very big, but it does have a very wide field of view, and it's in a balloon. And these balloons actually, they're ridiculously high. How
Yeah.
fly they? So it's over something like 99.5% of Earth's atmosphere,
Right.
and that remaining 0.5% is basically irrelevant. And so it's like a space-based telescope
In terms of atmospheric interference.
in terms of atmosphere. Right, because
Which
Oh, that's great.
degrades your
on-
focusing and it absorbs some wavelengths of light. So
Right,
yeah.
right, yeah. All of our Earth-based telescopes, or up until the advent of what's it called,
Rockets?
Computers.
No.
Adaptive optics.
Adaptive optics. All of our ground-based telescopes were limited by atmospheric stuff, right?
Yeah.
So you just can't build them any bigger because your resolution is limited by the atmosphere. Now you can put a much smaller telescope up at the top of the atmosphere, and you're not limited by that. Now it's just the bigger the telescope, the better.
Right.
Anyway, so
How long does this? I mean, the balloon isn't up there permanently.
it's
of
not up there
course.
permanently, but I think it's meant to go. It sits up there. This one is up there above the southern hemisphere, and it's going to make many circles around the southern hemisphere. So
Okay.
it's up there for some time.
Around the South Pole, you mean? Sort of. I mean, what do you mean?
It's not. So it's not
Well,
orbiting.
think
It's just going around in like atmospheric currents, right? So it's circling around one of these like Hadley cells or something like that. You know, like you know what I'm saying?
No, it's not a Hadley cell.
Not a Hadley cell,
At
but
least
like
that goes
that's
the wrong direction.
Yeah.
Jet stream.
yeah,
Sort
jet
of
stream
like
kind of thing.
so it's the southern equivalent of the jet stream.
Right.
What our northern jet stream.
Right.
That's what I meant, like around the
Something
pole.
Right.
Circumpolar,
Right.
circular.
Okay.
Right.
Yeah.
And
Is
so it's going to be up there for some period of time. It's going to make a soft landing. Like, do we get the telescope
Yes,
back?
they've tested it a bunch of times, and it has parachutes when it comes back down.
And it lands in the ocean somewhere?
I don't know where it
The
lands.
southern
But it's up there right now.
Pacific and southern.
Yeah, it's up there
Yeah,
right
there's
now.
a
and it's
website
taken
you can
pictures.
track with real-time GPS data, like where
Really?
it is.
Where is it
Yeah.
now? Oh,
I don't know if it's at the
Somewhere
beginning.
over a
Which I
southern
don't know which of
ocean.
these points.
No, but yeah. You see, it's kind of making a
Near-
circle, a
somewhere
great
near
big circle around
Australia.
Antarctica.
Yeah. Oh, it's currently at, as of today, it's at 49 degrees 53.90 south and 119 degrees 3.31 east.
The thing I don't know
At
how
107,000 feet.
Right about the height
Whoa.
that the starship exploded, coincidentally.
Right.
Coincidence? Yes. Yes, it
Yes.
is.
Yes.
Yes.
But anyway, it's a cool thing. It highlights. By the way, it's, you know, it highlights a bunch of cool things. It's much less expensive than something like JWST. Obviously, it's not as good because it's not as big. It's not up there for as
Right.
long as whatever these things. But like, you could build
Well,
a million
I mean,
of these things.
It'll come back down, then you send it up again.
You set it back up again, right?
Right.
And so,
But it transmits
Especially
its
if the
data.
payload survives.
yeah.
Mm-hmm.
And this one is actually cool for me because it's intended to be like looking at large scale structure of the universe and looking at distribution of dark matter by measuring gravitational lensing in galaxies and stuff like that. And you can just, because it stays up there for a long time, you can do these kind of survey type of things. Where at JWST, you're never going to
And
get to look at
it's-
anything for any length of time
The
because
name-
everybody wants to use
The
it.
name again is
Superbit.
Superbit.
Super pressure balloon borne imaging telescope.
Say it again.
Super pressure balloon borne imaging telescope.
Balloon born is hyphenated, so you
Safe
only
it is.
count one of
You
the
only count one of the
Yeah.
bees,
What-
apparently.
And why is there super pressure? What does that mean?
Because it's a pressurized balloon.
Okay.
It's got to have super pressure to get that high.
It's
They
got a lot of helium.
operate in the stratosphere via NASA's superpressure balloon system.
Okay. So, all right. Cool.
I don't know, it's just a cool thing.
That
like
is a cool thing.
you can do really awesome astronomy cheaper than the JWST.
Yeah,
Okay.
and there's interesting things you can do with balloons. So balloons are cool for those sorts of things, but they're also cool for looking down
Yeah,
on the
absolutely.
Earth
Yeah.
and doing like imaging over time of atmospheric stuff or ground-based stuff. There's a bunch of different companies
They're
that are
gonna look
working.
in
There
our
are a
backyard.
ridiculous.
And this one hasn't even been shot down yet.
Yeah,
'cause
I was going to say
it's over.
there are way more balloons up there than you might
Oh yeah,
think. Like
but like good sciencey balloons.
a lot of good sciencey balloons and a lot
Yeah,
of
let's
good
keep 'em
balloons
up
that
there.
like just like
Yeah.
clubs put up weather
Yeah.
balloons and then forget about them or not.
The
forget
astronomy
about them,
club
just
here at
stay up there.
UCF does a little weather balloon
Yeah.
like
Yeah.
every couple of years.
Yeah.
Aw.
So,
But those
I'm
are much
surprised they don't
smaller
get shut down
and
more
not as
often.
high altitude as this.
Yeah. You know, we're going to go actually straight to our trivia
I do know
Ooh.
that
before
because you just told me.
asteroid Mars.
Okay,
Okay.
Seems
That's fine.
reasonable.
I don't mind.
Oh shoot, I lost my.
And we have
trivia.
special top core
Special
trivia.
top quark trivia.
All right.
We need to make a song.
Here's
for
your
that.
special time. So last
On
night,
sheet.
He's got his computer.
last night,
down
don't
too.
cheat. Last night, well, today we're sitting here in the studio here in
True.
Central Florida, which is part
Fact.
of. It is fact. True.
Nailed one.
It's part of. What do we call it? Lightning Alley, something like that.
Oh, maybe.
Yeah.
Central Florida
Central Florida
is
is one of
is
the-
one of
Lightning
the
capital.
highest, is one of the lightning capitals of the world. It's not the place with the greatest
No, we've
lightning
had that as a
concentration.
trivia many years
We
ago.
have had
We
this
did.
trivia.
Good. So we're coming back to lightning trivia. We're not going to ask about that specific thing.
Okay.
It's not lightning round. It's just lightning trivia.
But there's that we today had lightning storms, which was very exciting, which was making me think of that. And
Often
also,
called-
last night,
also called
I was sleeping and had a dream that I got hit in the head with lightning.
Was it a dream?
Like whacked or like?
Like, it hit me
Okay.
in the head, and
don't
it
know,
came
just-
out of my face.
Oh, you were able to like
And I was okay.
channel
It
it
turned
out
out I
your
was
mouth.
okay. I was fine.
You went
I was fine.
with the lightning.
Like
So we just have
Aang,
some,
the Last Airbender.
Yeah,
Oh, I
exactly.
did not see that. I
Okay.
So we just have some lightning trivia today.
Okay, great. Good
Your
setup.
first bit of lightning trivia is: how many lightning strikes per second on average happen on Earth?
I kid you not. I looked
Don't
this
answer
up.
now,
I know, but
Don't
I
answer
looked
now.
this up a few months ago.
and you have no idea.
Completely left your
Not
brain.
gonna help you?
Yes.
Not
No.
gonna help you.
Okay.
If I looked it up yesterday, I probably still wouldn't.
Yeah, same.
And then also, there are a couple of follow-ups. Like, if you just one of the follow-ups now is this: I'm actually terrified of lightning, my own self, bordering on a phobia. Partly because two of my favorite pastimes are fishing and golf, and those are like the two ones that
I know you liked golf.
I
I
did.
don't know. I don't know if you did or not.
I
but
knew that.
But,
I do. I
but
don't golf
both
a
of
lot.
those,
You and your
both of
bro
those
go
Both of
like
those are not.
involve
Involve
waving
putting
a
a stick
lightning rod.
into-
Yeah, waving a
Yeah.
lightning
Yeah.
rod,
Sky.
and especially here in Florida,
Play
like
golf?
a significant portion of the people who get hit and/or killed are doing one of those two
Because
activities.
not only are you sticking a lightning rod in the sky, you're also usually
In a
in like
wide
an
open
open
You're in a
area.
wide open space. You're the highest thing,
Yeah.
and yeah. So I'm afraid of it. So the other question for our word nerds is, what is the name for the fear of lightning?
Oh,
Oh, fun.
fun.
Okay,
All right.
we'll come back to that.
Props to
Towards
the
the end.
trivia.
All right.
I appreciate it. Those are good trivia. All right, let's move out beyond. Audrey's unimpressed, but we'll move out. We'll move out into the solar system and talk about Mars.
Ooh, yeah, Mars is cool for a couple of reasons. Sorry.
We're going to talk about water on Mars.
Water on Mars.
Sort of.
Again?
Wait, what?
Yeah. So
Dun, dun,
not
dun,
current
dun.
day.
Yeah, so there was a lot of water on Mars, and there's a lot of evidence for that. One of those things being there are channels and deltas that you can really only get with active water or fluvial activity. There's also a lot of minerals that are only formed when there's a lot of water present at certain temperatures. So it has to be warm enough for liquid water to exist and to exist for a long enough time for that liquid water to start flowing and to start making these different fluvial morphologies, essentially. And it's been a big question in Mars, in the Mars community, like why was Mars so warm? Like what was giving rise to this heat? And
The sun.
that's
Not
what,
just the sun.
That's what a lot of people say. But at the time that all of this water would have been like actively flowing around Mars, the sun was actually dimmer and
Faint
like,
early
it
sun.
was, so that couldn't really be it, and it wouldn't really. That doesn't explain.
Greenhouse effect.
Greenhouse effect. I was going to say.
Yeah,
Mars
so-
atmosphere now
But
is
how do you
mostly
make a
carbon
greenhouse
dioxide.
effect?
Yeah. So how do you get the greenhouse effect?
You have an atmosphere. Volcanoes.
Volcanoes.
I teach all this
Not
stuff, so
enough.
keep them coming.
Not
I have
enough.
answers for all these.
It's
Not
not
enough volcanoes.
There
What?
are
Not
no
enough stuff in
volcanoes.
the atmosphere.
Yeah.
Olympus Mons. Big Biggest
volcano.
volcano in the
Huge!
solar system.
Not the right timing.
Not the right timing.
Oh,
So
I
what?
don't think we know enough about Mars, Josh.
I'll give you a hint. You already
What's the
said
other
it.
thing that often happens in things in space?
Collisions.
Collisions,
Yeah.
impacts.
I kind of knew that answer was coming though.
Good,
so
yeah.
I don't really. I
Good.
don't feel like I deserve any credit for that.
Sure,
one.
that's
I'll give
fine.
it to you.
And this has actually been also like an asteroid impact or an impact has been an idea in the community for a long time, actually, for a way to make transient warm periods on Mars.
Okay, so
Yeah.
now I got to ask you a question here. So
Sure.
the impact, I always thought impacts were like the nuclear winter scenario, and that's what killed the dinosaurs. Is there's an impact and it puts a bunch of stuff in the stratosphere, which blocks the sun and it makes it colder. So
Yes, I
help me
think
out
for
here.
Earth, yes. This is different because there's different stuff on Mars. So there was
You get different stuff in the atmosphere too.
right, yeah. So there was CO2 in the atmosphere. A part of the hypothesis is there's already CO2 in the atmosphere, but
Okay.
just the CO2 isn't enough to heat up the surface so that there's
Okay.
running water. the idea is that the asteroid comes, hits the surface, and it has to be an asteroid that's bigger than the one that killed all the dinosaurs.
Okay.
It has to be
A big sucker.
Yeah, one of those big old ones, and that causes what's the word I'm looking for?
Different rocks.
Vaporization.
Oxidation.
Oxidation.
It causes oxidation of iron and iron-bearing minerals, and then there's some chain effects, and
You increase hydrogen in the atmosphere.
you end up increasing hydrogen in the atmosphere.
Okay.
And when that happens, there's a lot of friction in the atmosphere, and the friction of the hydrogen and the carbon dioxide together heat up the atmosphere and can get it hot enough for liquid water to be present on the surface of Mars.
What?
Yes.
This
Friction
I
between
don't know about the
hydrogen
friction.
and carbon dioxide heats up the atmosphere. Now, okay, I have so many questions
Okay.
because I'm unprepared.
Great.
So the questions
So
are,
fine.
does the impact... First, the impact delivers a whole bunch of energy to the
Yes.
planet,
Yeah,
right?
yeah.
And then you do things with that energy, so you do some chemical reactions, and you can also loft a bunch of stuff and change the composition of the atmosphere.
Yeah.
So does the atmosphere become more of a greenhouse atmosphere as a result of the impact? Is that part of it or not part of it?
So there's like this study isn't looking at as much, I don't think, at the immediate atmosphere you get from the impact and from the stuff blown up. It's more of a
Okay.
long term. You get this impact melt that changes the surface that then is interacting differently for a longer time
I
period
see.
with the
So
atmosphere.
you sort of change the overall aerochemistry, not geochemistry, but you change the martiochemistry
Right.
of the planet and its surface atmosphere chemistry and interactions by essentially changing the composition of the surface somehow.
Right, yeah.
Yes.
And yeah, it's called collision-induced absorption. So the friction that I was talking about, what it's called is collision-induced absorption, and our own Ramses
Yeah.
studies this and says that these molecules
One of our
can...
colleagues here at UCF
Yes.
for confused listeners around the world
And
wondering
who's our
what our
Ramses?
own Ramses is.
And these molecules, he says, these molecules can become even hotter, or they're better greenhouse gases. So it does a better job of warming the surface than the traditional
Well,
greenhouse gases that
I mean, like
we
methane
think
is
of.
a very effective greenhouse gas.
But
for
it's hard to get
example.
that much. You don't get methane as much from these sorts of impacts, I don't think.
Okay.
So is this all just? This is, to be clear about what this is. This is just a hypothesis, right?
This is a hypothesis.
This is just some
It's a model.
that
It's
has
a
been worked
model.
out.
But it can...
Is it based on any new evidence, or is it just like, here's an idea for how we might have done that?
The new thing is that it can work. It can get this hypothesis, or this model can make the surface warm enough to have liquid water.
New model results, in other
Yeah.
words, is what we're
Right.
talking about.
Yeah.
Right.
So this is very sad making for Jim,
Why?
Oh.
because this would indicate because
Well, I shouldn't have
I
brought
didn't
it
realize
up.
it because then wouldn't that indicate that the water was probably only around for a
Oh.
geologically short
You
period of
want
time?
there to be Martians?
Then there's not going to be Martians.
There's not Martians.
I
There's
don't
not
think there's Martians. Sorry,
I've
bud.
been
You guys,
I've
what?
always been a Martian skeptic.
I mean, most of our hypotheses for how long water is on Mars is relatively geologically relatively
Yeah.
short-lived.
I am crushed.
Really? You're a very fragile person.
Are you
Uh,
crushed because it was an
lightning-
impact?
I had heard previously there had been this, many years ago, there had been articles about whether the sort of warm periods on Mars were sort of episodic.
Yeah.
Is that related to this, or is
Can't
this
be.
different?
It could be. I think, from what I understand, one of the biggest kind of holes in this idea is the timing of the fluvial activity and of the giant asteroid impacts. And there are quite a few impact basins that are big enough that that the warming could be attributed to. So I guess it is possible that with each impact comes like an episode of warming, which then induces, heating that warms up the water and then the water can flow. It's possible, but I think that's something that these researchers still have to figure out.
So it seems like the hydrogen that gets released into the atmosphere collisionally excites the carbon dioxide, and that broadens its cross-section to infrared radiation, making it a better greenhouse effect. That's what I think the collision-induced absorption may mean.
Sure.
Is that you have, low mass and therefore more rapidly moving hydrogen colliding with your CO2, and that gives you a sort of spectrum of excited rotational or vibrational states, perhaps, that then gives you a broader ability. That's what's making them these more, maybe I'm making stuff up, but it sounds pretty good, so I'm going with it.
I'll take it.
Yeah.
I don't know if that's quite exactly it, but I think that's fine enough. That's close enough for our work.
Yeah.
Yeah. Wait, there we were. Just like
I mean,
I just sold the story,
to Jim's,
Addie.
I know it was a great.
And then you came in and said,
sales pitch.
"Yeah, but not that."
No, I mean, I think to your question, Jim, right? Like, is it a new? So it's a new model. There's been previous models of asteroid impacts, and it seems like they don't last long enough. So maybe you have transient atmospheres, but they're not long enough to like sustain this sort of melting that we need. There's other models that show you need more hydrogen in the atmosphere, and so but it's hard to like make enough hydrogen from other ways. So I think this is sort of like a way to explain some of those different things. And they're like, if it was episodic, maybe it was during some heavier bombardment, right? Maybe you could have had a little bit longer lived wet conditions, but you also have a lot of impacts during that time then potentially.
So
there's
can
some
you give
like
me
big basins on Mars.
Do we have a can you give me a rough order of magnitude how long
No.
the water's around?
No.
Well, they said
10 to the 6 years.
that's,
Is it
yeah,
6?
that
That's
works.
an order of magnitude.
Okay, that's what I'm looking.
That's in the paper, so yeah.
I was wondering because, like, I'm trying to keep my Martian hopes, my Martian dreams alive.
Potentially up to several million years in the Noachian, which is pretty early
Mars
in Mars
days.
Right, but that's still not very long to get life going.
No.
I mean, you never know.
You never know, but I ask
We
because
also
on
don't
Earth,
know how long it is to get like baby life going.
we don't know. We don't
Yeah.
know because we only have one.
Darn one data point.
One data point, but life did arise on Earth. We don't know
Life
exactly how
finds a way,
quickly, but it did fairly
That's what I
quickly.
hear.
But fairly quickly means in a few 100 million years after the conditions got right at some point, but we don't know how fast. So
Yeah.
I would say if it's only 1 million years of water, then I'm probably screwed.
Well, and even if there was life, it might have gotten totally erased by the next impact.
Right, and and that very, very early life would just leave nothing to ever find. So
Yeah.
Maybe the early life is happy because it doesn't get impacted in the same spot, and so then it gets to thrive.
And then it gets buried deeper and deeper, and now there's a whole community of
Subsurface Martian life.
Yes!
Martian.
There you go, Jim.
okay, thank you.
That's where it is.
Yep.
And I'm sticking with my
That's
my
fine.
hand wavy definition of collision induced absorption is when there's inelastic collisions of molecules in a gas, which means that energy is being converted from the kinetic energy of those molecules into something else, which could be internal energy states of those molecules,
Sure.
which then gives them a different spectrum.
Okay.
Cross-section, yeah. Anyway, impacts to the rescue once again to
Always-
explain
Always a good,
all the
always a good
mysteries
solution.
of planetary science.
Always a good solution.
Yeah. Further out, but still planetary, and that rarity of rarities, a top quark planetary story.
Oh yeah. I just saw this because this is a cool, almost intersection of the scales that I like and the scales that you guys like. Most of the time when we're looking for planets and planet-forming regions, it's of course inside our galaxy because, And
usually
biased.
on our corner of the galaxy.
Yeah,
too.
because you need things fairly close by to see these things. Anyway, this is a look at a region in not our galaxy, but a nearby galaxy,
Okay.
the Small Magellanic Cloud.
Oh, very
Aw.
nearby.
Very
SMC.
nearby.
Okay.
Yeah, little guy. But the idea was using JWST to look at
SMC.
a region of the SMC, Small Magellanic
We're only
Cloud.
allowed to speak in
In letters.
letters.
Um,
You can add some numbers.
yeah, specifically the object is NGC 346. It's a little
Perfect.
star-forming, little star-forming region in the Small Magellanic Cloud that is. And the reason it's fun and interesting is it is very low metallicity. Is a fancy word that we use in astronomy, which basically just means it has a very low concentration of elements heavier than helium.
Right.
There's a lot of hydrogen and helium, and very low compared to solar metallicity, which is the
gold standard.
Yeah, the gold standard.
And low metallicity often means it's like
Old.
older because you don't have time to make
Right.
little
Top
more
2
fancy things.
stars or something like that.
Right. Right. And the idea, the thought had always been it's going to be hard to make planets in star-forming regions where there's low metallicity.
Right,
when
because you can't condense hydrogen or helium.
To make
Right.
You
planets.
need what astronomers call metals to make anything
Right.
solid.
That's right. That's right. And the more that you have, the heavier the elements, the better you are, the more stuff you have to make these stuff. So yes, it's going to be hard. I mean, in astronomy, we use the word dust to mean little bits of
Little
solid
solid
stuff. And so this, the question is there going to be enough dust? And the dust that does arise, is it going to be long-lasting enough to form planets? Or is it just going to get, if there's just a little bit of it, it's going to get all blasted apart by the radiation from the sun and everything or not the sun, the stars once they turn on. So these guys were using, and there just hadn't been, it's hard to look at this kind of stuff, especially far away, without a really good infrared telescope.
Yeah. And the other problem with dust is that it often blocks the light that you're trying to look at.
Right, it does. Dust is fairly...
A lot of astronomers hate dust.
Yeah. Most astronomers, right? If you're trying to look at anything in the plane of our galaxy, it sucks because of the stupid dust from our galaxy. Anyway, but infrared light, a lot of infrared light does penetrate through dust, and so you can look at forming star systems.
Okay, so we see dust even though it's a low metallicity region. Is the whole Small Magellanic Cloud a low metallicity?
No, not necessarily. Although I think the mean metallicity of that is lower than our galaxy.
So
but
this
is a
particular
specifically
area
region.
is a cluster. It's like an open cluster. It's like the Orion or
Yeah.
Pillars of Creation or
Exactly.
some of these things.
Exactly. And
And
I don't know enough
those-
about this to know why it's specifically so
But those
metaphor,
specific stars that we see there are low metallicity.
Yes, on the order of like 10% of the metallicity of our sun, so much lower fraction
Okay.
of heavier elements. And this is actually very similar to the situation, I don't know, they say it's similar to what we call the cosmic noon, which was a period...
I hear about the cosmic dawn a lot. I haven't heard a lot about cosmic noon.
Cosmic
This is
noon,
exciting.
yeah, I don't
This is
see
where
that.
the
hear
duels
that.
take place.
But that's a kind of a region, or a period of time when there was a huge explosion of star formation in the early-ish universe, like in like 1 to 3 billion years after the Big Bang kind of time. Because too early, there's star formation, but the constant formation of big stars and then blowing up causes everything to be too hot to form a lot of stars, and then eventually the galaxies collect
Calm down
enough
a little
stuff,
bit.
there's enough gravity that you can overcome that pressure from all the blowing things, and then all of a sudden you have this explosion of stars. Anyway, but back then the metallicity is low because there hasn't been very many generations of stars.
Yeah.
And so this is a similar region to that, and the question is, are you going to make a lot of planets in a time like that?
Yeah.
And the answer is, they found that yes, you're still going to make planets that unbelievably, or I don't know.
Cool. So that means there could be some ancient aliens.
Yeah, that means there's
Smarter
probably,
than
that
us.
probably means more planets in the universe, more planets in the galaxy, more planets than you would have
We might have
naively
otherwise thought.
Are these
Which makes the Fermi paradox
I mean,
more of a
I
paradox.
will say that they detected like dust and like planet forming regions.
Yeah,
They
right.
didn't
They're not seeing the
necessarily
planets.
detect
Exactly.
I haven't
planets.
seen the planets yet.
Right, and again, this is in a different galaxy. I mean,
Yeah.
I mean, it is a
It's
satellite
neighboring.
galaxy of our own Milky Way, but still, it can be really hard to see.
Right. It
But
does make
planets
the
could be
Fermi
there.
paradox slightly paradoxier.
Yeah, paradoxicalier. Yeah.
Yep. those
Well,
are
speaking
words.
of explosions, lightning strikes.
Lightning stri-
We're supposed to
Oh.
guess, or supposed to know
All right.
Oh, I don't
how many per day or per second.
How many per
or-
second? We'll say per second. So on Earth,
on
at
Earth.
any time, there's probably a thunderstorm somewhere.
Right.
on Earth, how many lightning strikes per second on average, obviously?
Maybe go in the Wayback Machine to a previous episode. I feel like we discussed
It's possible this has been discussed.
But it was a long time
we're,
ago.
We're
Yeah.
getting old. We forget these things.
Okay.
We're gonna, except Audrey, she's not. She's getting younger.
Lightning strikes per second, and that includes like over the oceans.
Yes.
Yeah.
Everywhere.
That we can
Luckily, we
detect,
have
I guess,
again. We
so.
have these satellites that orbit
yeah.
the Earth. That
1,000.
1,000
I
lightning
was gonna say
strikes every
1,000.
second. Okay. And
Yeah.
Audrey also wants to say
100.
100.
500.
One.
1.
No. A million.
Are you sticking with 1,000?
I'm sticking with 1,000, even though he gave me a "what kind of idiot are you" look after I
No.
said that.
Maybe it should have been larger.
Maybe
No.
it should have been larger. Maybe it should have been smaller.
I said
Maybe Josh
500.
is an idiot. Maybe he's a genius.
What's
We'll
the
see.
answer?
Tell us.
Did you guess?
I said 500.
Oh, you said 500. No, we're gonna give it to who said the lowest one? It's 44.
Audrey.
44? I said
44.
100. That's
You
so
said 100,
low.
so I'm gonna give it to Audrey.
Because I did
I
look
think
that
that's
up.
appropriate.
That seems...
Absolutely, 44. So I mean that maybe I shouldn't have said per second. Maybe I should have said per day or something, and you might have guessed lower numbers overall. But that's still a lot. I mean,
That's a lot.
to me,
Yeah, that's a lot.
you
It's a
think
big
about
Earth.
it, and I
There's
mean it's
lots of
only
storms all the
even
time.
Impressed. I
even.
thought it was going to be 1,000, so I'm like, whatever.
44.
Ugh, only 44 per
Only
second. I mean,
44
per
per
second,
second.
though. That's so many.
Every
like,
second,
every...
44 lightning.
I feel
bolts.
like that doesn't super surprise me though. I feel like whenever they show those
The Earth is
ISS
big.
flyovers, there's always a lightning
Lightning.
storm somewhere.
Yeah.
Yeah.
in
No, there
the
is. There
nighttime.
are always lightning,
Yeah.
lightning storms
And
around, but
that also includes, like, cloud-to-cloud lightning.
cloud to cloud,
Yeah.
ground to cloud, yep, all that stuff.
Yeah.
All right, all right.
Okay.
The second question was fear of lightning. Does anybody know what that's called?
Oh.
Zapophobia.
Zapophobia. I might give you credit for that, even if I get one right.
Fear of lightning.
Fear of lightning. Tribophobia.
Tribophobia.
Oh, I like it. Zeusphobia.
Yeah, Thorophobia. It's astrophobia.
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 What's the
Astrophobia.
etymology?
I don't know.
Oh.
I'm stupid. All right,
No.
one more.
Okay.
Recently, fairly recently, in the last decade or so, they made a measurement of the single longest lightning bolt seen.
We definitely
We
talked
def-
about
did?
this.
That was
We-
a-
we
that
did
was
it.
a thing?
We like
That
talked
has been
about
a
it.
past trivia.
I don't know if it was trivia, but I think it was a.
Well,
oh,
Audrey
okay.
wasn't around for that, so this is a question only for Audrey.
Oh, God.
I mean, I don't remember.
Oh, so how long was it?
Uh,
I don't remember this clearly. If I was here for that show, I don't remember how long this was. Because
I don't know how long, like, a normal, like,
Well,
the
sure,
average...
you know
I
how
don't
high
know.
a cloud is, so you know cloud to surface lightning.
But cloud to cloud, and I don't know,
Well, that
like,
gives
the
you a
number
length scale.
5 kilometers.
5 kilometers,
Do you remember?
No, I
don't
don't
remember exactly. I
remember.
say 100 miles.
100 miles.
Oh, we're mixing our units now.
160 kilometers then.
Okay.
Kilometers.
In
We're
light-
going
in light years.
miles. I like miles.
Okay,
How much
100,
did you say?
100 miles is what you said?
I said 100 miles, 161 kilometers.
Mm-hmm.
I'm going to say 200 miles.
Yeah, it's 477 miles.
Oh, man, I'm so
It's
wrong.
and this was in the southern
So you got
United
the first
States,
one
from
right.
like
Yeah.
Texas to
To-
Georgia or something,
right,
like some
yeah.
ludicrous.
When was that?
But it was a chain reaction spark.
Yeah,
Yeah.
some. I
Still
don't.
counts.
It
Bizarre.
wasn't like there's a cloud here and a cloud here and then a single instantaneous
Aw.
spark connecting
like in
them.
Harry Potter.
But it was just like, right.
when him and Voldemort were...
And there was a big one also in South America too, if I recall.
Yes, I think that was
Correctly.
the in Brazil. That was the record holder before this.
Before the Texas.
From the
one.
Greek astrape, meaning lightning.
Astrape.
But it
Oh.
can also be brontophobia, which makes it sound like you're scared of dinosaurs.
Yeah, it
Yeah.
does.
Or scared of Little Women.
Oh,
Bronte.
I don't get it.
I don't think so.
I think that was
That's
Louisa
you're
May
mixing.
Alcott.
Yeah, you're mixing your
Oh
authors.
shit! Who did
Yeah.
Bronte?
Emily and
Bronte
yeah,
wrote
I don't
The-
know.
The
Wuthering
Bronte
Heights.
sisters?
I don't know.
Yes.
What a
Yeah,
great
okay.
end of the episode.
Yes,
Well,
this
How
is-
just-
smart we really are.
Wrapping it all up, while it may have felt like looking for a 5 sigma detection, it was just another episode of Walkabout the Galaxy. Give us 5 stars or 5 sigma,
Oh.
and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions via the ancient technology of email at wtg@ucf.edu. Our theme music was composed by Richard Drusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in North Carolina and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
And I'm Audrey Martin.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy.
Zoinks.
Zap.
Zop.
Oh.
Jim's got
You're
nothing.
supposed to say zap.
Gems.
Zip, zap, zop.
Zap, zap.
You don't